In this video we're going to look at how to convert gray code to binary. So recheck your explanation in the book of gray code and binary, which we've been over before, and why gray code is used. It's a number system where only one bit flips at a time. In binary, when you're jumping up, for instance, from 3 to 4, then we have to flip 2 bits at one time. We have to set this to 0, 0, and this one to 1. But in this coding system, only one bit changes at a time. But we're going to focus on how to convert this. And to convert this, we're going to use XOR. So remember using exclusive OR. If we have two inputs, in this case A and B, we look at all the possible combinations by creating a truth table: 0, 0, 1, 1, 0, 1, and 0, 1. That's every combination of inputs A and B. With an exclusive OR, you only have a 1 or a signal going through when one is true or set to a 1, or the other is but not when both are. So we put a 1 here and a 1 here, and then we have 0 here and 0 here. With an OR, we would have had a 1 down in this row also, because it can be whether A is true or A is set to a 1, and B is set to a 1, or both of them set to 1. But with an exclusive OR, it has to be one or the other and not both. So using exclusive OR, we start with, let's clear this out, we're going to start with the gray code, or the binary code rather, and we're going to develop the gray code. So first of all, we've got a binary 4 here. Let me delete this. We've got a binary 4 here, and we bring down the most significant bit. Remember, the most significant bit is the furthest to the left. The least significant bit is the furthest to the right. So we bring down the most significant bit, then we use XOR on the binary code between these two bits. So 1 or 0, remember, a 1 or 0 gives us a 1. So then we put a 1 down here, and then we move along. A 0 or 0, 0 or 0 gives us a 0. And then we do 0. And if we want to check our answer, if gray code 4, we look at gray code 4 and we see it's 110, 110. And that's the gray code 4. Let's try it again with gray code 2. In this case, we bring down the most significant bit, and then we do 0 and 1, which 0 and 1 gives us a 1, so we put a 1 down here, and then we do 1, 0, which also gives us a 1. And if we check our gray code 2, we see that our gray code number 2 is 0, 1, 1, so it works. Now we'll look at converting gray code to binary. Now I'm going to convert gray code to binary. I'm going to do it for 2, 4, and 5. So we'll start with the gray code for 2, which is 0, 1, 1. I bring up the 0, or down, it doesn't matter which you do. But this time I do my XOR this way. So 0 and 1 is 1, and 1 and 1 XOR is 0. You see 1 and 1 is 0. And we end up with 0, 1, 0, which is the number 2 for binary. Let's try it with the number 4. I bring down or up the most significant bit, and then I go diagonally this way. So 1 and 1 equals 0, and XOR 0 and 0 also equals 0, and I end up with 1, 0, 0, which of course for binary is 1, 0, 0, and that 1, 1, 0 is the gray code for the number 4. One last example here. Bring up the most significant bit. This is the gray code for number 5. Then 1 and 1 is 0. 1, 1 equals 0. So I place the 0 here. And working diagonally, 1 and 0 is 1. And that is, of course, the binary number for 5. And there's 1, 1, 1 is the gray code number for 5. And that's how to convert from gray code to binary. So work through those two examples from binary to grey code, and from grey code to binary, and a few examples till you've got it, and then you'll be able to do any number, no matter how many bits it has. Most numbers above, all of the numbers above 4 or above 3, the most significant bit will be a 1, and you'll be bringing down the 1. But numbers under 4, the most significant bit will be a 0. So it doesn't matter, just bring down the most significant bit. That's grey code. Thanks.